Hey Math 20-2s. Today we're going to look at solving quadratic equations by completing the square. Alright, so let's just recall how to solve a few quadratic equations. Let's say we got x squared equals 169. First step here would be to maybe set the equation equal to 0 and then factor it. So this is a difference of squares. Remember how to factor a difference of squares. Square root of the first term is x, square root of the last term is 13, so you make them conjugate binomials. X plus 13, x minus 13 equals 0. Set each factor equal to 0 and solve those simple equations. X would equal 13 or negative 13, or we could say x equals plus or minus 13. That's not the only way to solve this equation. There might be a simpler way. We could take the square root of both sides. So x would equal plus or minus the square root of 169. Now 169 is a perfect square, so the square root of that would be 13, so we get the same solution, x equals plus or minus 13. That method works over for the second equation a little bit easier. Rather than expand out this bracket and set the equation equal to 0, we can take the square root of both sides. So x plus 4 would equal plus or minus the square root of 9. Now we're going to isolate the variable x by subtracting 4 from both sides. And the square root of 9 obviously is 3. And we can now simplify negative 4 plus 3 and negative 4 minus 3. So that gives us solutions of x equals negative 1 and x equals negative 7. Do the same thing down here for this equation. Let's isolate the variable, add 8 to both sides. Divide both sides by 2, so we get x squared equals 24. We could now take the square root of both sides, so x equals plus or minus square root of 24. And now we're going to simplify this radical. We did that in grade 10. So 24 is the same as 4 times 6. 4 is a perfect square root of 2. There is no square root of 6, so x equals plus or minus 2 root 6. And let's look at this last one. How do we go about solving this one? Well, if we look at the last two equations, there was only one variable x, actually in all three of these. Here we've got an x squared and an x. Hard to isolate this. We could set it equal to 0. But this is not factorable, so all sorts of weird things start happening on us. All right. Okay, so let's look at some groundwork for this section. I want you guys to expand and simplify the following. We've squared binomials lots. Remember, if you're going to square x plus 1, x plus 1 times x plus 1 should give us x squared plus 2x plus 1. So x plus 2 all squared, square the first term, x squared, multiply two terms together and double it, so that gives us 2x doubled is 4x, and then square the last term is positive 4. Same thing here, x squared, multiply two terms together, 3 times x doubled is 6x, and square the last term is a plus 9. So I'd like you to go ahead and complete the rest of these, pause the video, and do that. So this is what we should have if we complete all the questions D, E, F, G, and H. And if you also complete x plus c all squared, again you should square the first term, multiply the two terms together, which is x times c, and double it, so 2c's times x, and then square the last term, c squared. So let's answer these questions. What do you notice about the first term of each expansion? It's always the square of the first term of the binomial. What do we notice about the last term? Well, it's always the square of the second or last term in the binomial, right? 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. C squared is c squared. All right. What do you notice about the middle term in the expansion? Well, 1 times x is 1x, doubled is 2x. 2 times x is 2x, doubled is 4x. 3x times negative 3 is a negative 3x, doubles a negative 6x. So that middle term is always double the product of the first and last terms in that binomial. So let's do a quick review of what a perfect square trinomial is then. Let's say you're asked to factor x squared plus 6x plus 9. Well, we know that factors to be x plus 3 times x plus 3 or x plus 3 squared. So we call this a perfect square trinomial. And the factors will always be a binomial squared. All right. So very important to notice the relationship between the middle term and the last term. the last term is half the middle term squared. So 9 is half the middle term 6. Half of 6 is 3. 3 squared is 9. Right? Half the middle term squared will give us the last term in the perfect square binomial. Or sorry, perfect square trinomial. This becomes a crucial step if we're going to solve quadratic equations by completing the square. So let's find the value of the last terms that will make the following perfect square trinomials, and then let's factor them. So x squared plus 14x, based on what we learned here, to make this a perfect square trinomial, we have to take half the middle term, which is 7, and square it. So 7 squared is 49. If you're asked to factor that then, well, this is a perfect square trinomial. It factors as x plus 7 all squared. What about x squared plus 7x? Well, you take half of 7, which is 7 halves, and square it. 7 squared over 2 squared. If I want to factor this then, that becomes x plus 7 halves all squared. And let's look at this last one. Take half the middle term, so half of negative 3 is negative 3 halves, and you square that, so negative 3 squared is 9, and 2 squared is 4. So we get 9 quarters. If I want to factor this then, factor as a binomial, x minus 3 halves. The square root of 9 quarters is 3 halves, and it's a negative sign in the middle, so x minus 3 halves all squared. Okay. We've now set the groundwork for solving by completing the square. But recall a couple slides ago we were asked to solve the equation x squared minus 8x minus 5. Well, how many solutions do we expect this to have? Well, we'd expect this to have 2 solutions, as it's a quadratic equation. A degree 2 polynomial equation should have 2 solutions. What are the solutions to this equation? So we tried to solve it, but this does not factor. No two numbers add to negative 8 multiplied to negative 5. So it's not factorable. Nothing adds to negative 8 multiplies to negative 5. We can't isolate the variable. We can't isolate just the x or just the x squared. That doesn't work real well. So all sorts of problems trying to solve this thing. So we have to find a new way to solve this kind of an equation. We do that by completing the square. So here are the procedures to complete the square. Anytime you're given an equation ax squared plus bx plus c equals 0, we're going to take these steps and finally solve for x. So want to make a equal to 1 if it doesn't. We can do that by multiplying or dividing. We're going to move the constant term to the other side of the equation, determine the value of the number that will complete the square like we just did in the last slide. Add that number to both sides of the equation to keep the equation equal. And then we're going to factor the left side and solve for x. So let's try a few of these. On x squared minus 8x minus 5 equals 0. Step 1, a already equals 1. 1x squared, so we don't have to worry about the first step. Move the constant term to the other side of the equation, so let's add 5 to both sides. Now we want to determine the value of the number that will complete the square. So in other words, we want to make x squared minus 8x plus something into a perfect square trinomial, just like we did last slide. So we take half the middle term, which is negative 4, and you square that. So we're going to add that value to both sides of the equation now. So add negative 4 squared, which is 16. So we're going to add 16 to the left, and we're going to add 16 to the right. That keeps the equation equal. Whatever we do to one side of the equation, we must do to the other. Now the left side we're going to factor. This is now a perfect square trinomial. So the factors of x squared minus 8x plus 16 are x minus 4 all squared. And obviously 5 plus 16 is 21. Now I've only got one variable here. I can take the square root of both sides. So x minus 4 would equal plus or minus the square root of 21. And I could add 4 to both sides to solve for x. So x would equal 4 plus or minus the square root of 21. We have now solved for x in this equation. So we didn't do it by factoring. We couldn't factor this. We didn't do it by isolating the variable. First we had to complete the square. So we get a perfect square trinomial, and then we're going to factor that as a binomial squared, which makes this easier to solve. So let's do the same thing for part B over here. Again, a is 1, 1x squared, so let's add the constant term to both sides. Right? Move the constant term to the other side of the equation. So we add 3 to both sides of the equation. Now I'm going to complete the square. So I look at x squared plus 6x, take half the middle term, which is 3, and square it, which is 9, and make sure I add 9 to both sides of this equation. Now I go ahead and factor the left side. This is a perfect square trinomial. It factors as x plus 3 all squared, and 3 plus 9 is 12. I'm now in a situation where I can take the square root of both sides, so x plus 3 is going to equal plus or minus root 12, and I can simplify root 12 as I subtract 3 from both sides. So minus 3, and then simplifying radical 12, well that's 4 times 3, the square root of 4 is 2, there is no square root of 3. So this is our solution. Negative 3 plus or minus 2 root 3. Let's try a couple more. A little more complex one. We've got a value that is no longer 1, so we're going to get rid of that a value. We're going to make a equal to 1 by dividing the whole equation by negative 5. So negative 5x squared divided by negative 5 is 1x squared, negative 10x divided by negative 5 is 2x, and 2 divided by negative 5 is negative 5 halves. Not true. Alright, so 2 divided by negative 5 would be negative 2/5. Alright, now we're going to move the constant term. So add 2/5 to both sides. I said 2/5, so there we go. And we want to complete the square now. Alright, so let's complete the square. Half of 2 is 1. Squared is 1, so we're going to add 1 to both sides of this equation. Next step, want to factor the left side. That's a perfect square trinomial. And simplify the right side. So let's get a common denominator and add these together. So factor this trinomial, you get x plus 1 all squared, and 2/5 plus 5/5 is 7/5. All right. Next step, take the square root of both sides of this equation. So square root of x plus 1 all squared is x plus 1. The square root of 7/5 is plus or minus square root 7/5. And now I'm going to isolate the variable. So let's minus 1 from both sides of this equation. At the same time, let's write this as radical 7 over radical 5, because it can be written like that. And we're going to simplify this. So negative 1 is the same as negative 5 over 5. And I want to rationalize this denominator. So I'm going to multiply the numerator by root of radical 5 and the denominator by radical 5. So radical 7 times radical 5 is radical 35. Radical 5 times radical 5 is 5. I now have two fractions with the same denominator, so I can simplify that. And the best solution we have here is negative 5 plus or minus root 35 all over a common denominator of 5. That's our answer. Beautiful. Let's try the same thing for D. Let's make a into 1, so I want to get rid of this 1/2, so I'm going to multiply everything by 2. So a half times 2 is 1x squared, 3 times 2 is 6, and negative 9/2 times 2 is negative 9. There, much nicer. Now if I could factor this, that would be great, but this is not factorable. Nothing adds to 6 and multiplies to negative 9. Though it looks like it might, it doesn't work. So let's go through our steps. Let's move the constant term, so let's add 9 to both sides of the equation, move that negative 9 over to the right side. Now let's complete the square. So half of 6 is 3, 3 squared is 9, so make sure we add 9 to both sides of this equation. Next step, let's factor the left side. So again, x squared plus 6x plus 9 is a perfect square trinomial. That factors as x plus 3 all squared, and 9 plus 9 is 18. Next step, take the square root of both sides. So square root of x plus 3 all squared is x plus 3. Square root of 18 is plus or minus radical 18. Now we want to isolate the variable, so let's minus 3 from both sides, and at the same time let's simplify radical 18. Alright, so minus a 3, and radical 18 can be written as radical 9 times radical 2. Square root of 9 is 3, there is no square root of 2. So radical 18 simplifies to 3 radical 2. So x should equal negative 3 plus or minus 3 radical 2. That's the exact solution to the equation in D. Alright. We got one more to do. Let's complete the square of this question. Alright. You guys try this one on your own. Pause it. See how you do. And then we'll do it together as a group. See how far you got. Okay, here we go. Step 1, let's get a to equal 1. So I'm going to go ahead and divide this whole equation by -3. So -3x squared divided by -3 is a 1x squared. 5 divided by -3 is a -5/3, and -1 divided by -3 is a positive 1/3. All right. Now I want to move the constant term, so it's minus 1/3 from both sides. So we get -1/3 is going to equal x squared minus 5/3 x. And now we're set to complete the square on the right side of this equation. So take half the middle term. Half of 5/3 is 5/6. And we square that. So 5 squared is 25, 6 squared is 36. So we add 25/36 to the right side. We must also add that to the left side. Over here on the left side, you can see I simplified these two now. So I'm adding two fractions. 1/3 is the same as, -1/3 is the same as -12/36. I'm going to add that to 25/36. And on the right side, I'm going to factor this perfect square trinomial. So half of 5/3 was 5/6, or the square root of 25/36 is 5/6. So this factors as x minus 5/6 all squared. Simplify the left side. -12/36 plus 25/36 is a positive 13/36. And I now take the square root of both sides. Get rid of this exponent 2. Isolate the variable x. So square root of 13/36, make sure you include the plus minus, and that equals x minus 5/6. I now want to isolate the variable, so let's move the 5/6 to the right side, so that becomes positive 5/6. And at the same time, I can simplify this. That's radical 13 over radical 36. All right. So there's no square root of 13, but there's a square root of 36. So this will become 5/6 plus or minus root 13 over 6. No square root of 13, but the square root of 36 is 6. And now I have two fractions of the same denominator, so I can simplify these by adding or subtracting. So 5 plus or minus root 13 all over 6 is the correct solution to this quadratic equation. Okay, that is completing the square. So here's your assignment. We will work on that next day. If you have any questions, don't forget to ask at the start of class. Any questions from your notes?